या पढ़ा है कि नहीं पढ़ा है? स्वरूप स्वरूप पढ़ा है?
पढ़ा है सर वो।
देविका पढ़ा है कि नहीं पढ़ा है? ओके, तो आज हम लोग पढ़ेंगे कंपाउंड माइक्रोस्कोप। तो सिंपल माइक्रोस्कोप में हमने देखा इट इज ओनली सिंपल सिंगल लेंस, सिंगल बाइकॉन्वेक्स लेंस. कंपाउंड माइक्रोस्कोप, simple microscope was not helpful because it used to do only 3 maybe 10x or 9x only. 9x zoom था उसका, so it is not helpful, we cannot see, it's not so useful. तो हम लोग को, so that's why we are studying compound microscope. Compound microscope magnification is very very large, and it is maybe 1000 times, 1000x times or more than that. So to understand what is how a compound microscope works, we have to understand its construction. So in a compound microscope we have two lenses, two biconvex lens. So first we'll draw the diagram. There are two lenses, okay. One is called objective lens, which is placed.
हेलो सर,
या
सर आपने स्क्रीन शेयरिंग चालू किया?
हाँ, नहीं दिख रहा है? अभी दिख रहा है?
हाँ सर दिख रहा है।
ओके, तो कंपाउंड माइक्रोस्कोप का दो लेंसेस है, एक है ऑब्जेक्टिव लेंस और एक है बोलते हैं आईपीस लेंस. जो आंखें, यहाँ पर आंख रहता है, तो जो आंख नजदीक है, which is closer to the eye, it is called eyepiece lens. And the one which is closer to the, which is the other one, is called objective lens. Why? Because it is close to the object. Initially the object is placed here. We will first see the diagram and then we will understand. Okay, so object is placed here, so the ray will come here. After the ray will come here, this is the optical center, this is another optical center. So rays will come here and then they will try to, so the focus of the objective lens is called FO. Why? Focal length of the objective lens. It will pass through the focus. After refraction it will pass through the focus, and there is another ray which will go, sorry, do with me diagram, which will pass through the optical center and will merge here, this point. Okay, and this point will be the image, the first image. It will be A dash and B dash. This image, the image of objective lens, will act as the object for the eyepiece lens. Similarly, what will happen? It will go like this, and here is the FE. Why? The focal length of the FE, and it will pass through the eyepiece. And there is a second object which will pass through the optical center and will go like this. So you know very well that they are not going to meet because they are divergent rays. So what we will do? We will extend it. Somewhere here they will meet. And what type of image it will be? Saurabh, what type of image it will be?
Inverted.
Inverted, yes. How inverted? Inverted, see, first you understand, we are not actually, these rays are not merging. We are actually backward. So first it is a virtual image. Understood?
Yes sir.
It's a virtual image. So virtual, the final image. See, this is the object. So the first object is this one. For this for this lens, this is the image, real inverted, and this image, real image, will act as the object for the eyepiece lens. And you very well know that whenever the object, whenever the image is the, see now, if you consider this one, this will be erect or inverted? Erect only, no? Because if you consider object like this, image is like this, then you say, okay, this is an inverted image. But if the object is this way, image is this way, or the object is this way, image is this way, this will be erect. Understood? The, you may say the final
Yes, sir.
image, the final image is the virtual image, erect image, inverted image, and the magnified image, final image. But if you consider eyepiece, it is a virtual image, erect image, and magnified image. Understood, everybody?
Yes, sir. Yes.
So write down first point. In the compound microscope there are two types, two lenses. One is objective lens, which is close to the object. Write down. And there is the eyepiece lens, which is close to the eye. The focal length of the objective lens is high. Sorry, it's a small focal length, and this is the larger focal length. So FO will be smaller than FE. You see, the distance from this one to this one is smaller than this one to this one. Yes or no? Yes or no?
Yes, sir.
So now we let us. So this is the U naught. Why U naught? Because it is the object distance. Similarly, this is the V naught. Why? Because we are considering, see, whenever VO and UO, that means for this lens, this is the object distance and this is the image distance. Understood? For this lens, this is the object distance, UE. Yes or no? The image of the objective lens will act as the object for the eyepiece lens. So this is the object. So this is the UE. Yes or no?
Yes, sir.
Huh?
Yes, sir.
And this is A dash B dash, A dash B dash, and this will be A double dash, B double dash. This is the final, and also we will also write this is the beta, the visual angle, beta. Clear or not?
Yes, sir. Clear.
So the virtual object, so the virtual object, which is the virtual object? So the, you can write the object, the image formed by the objective lens act as the image, virtual object. The image formed by the objective lens acts as a virtual object for the eyepiece lens. Write down. And the final virtual image, the final virtual image, that is A dash B dash, is a virtual image, inverted image. With respect to what? With respect to original object. You have to write down this. With considering this one, it is a inverted. But if you consider this one, this is a erect image. So you have to write down inverted and magnified image formed near the objective lens. Clear?
Clear, sir. Yes,
Okay.
sir. Yes.
So now see, I am trying to do this. So you have to write down. Okay, I cannot, because I need the diagram for explaining. So you have to write down because I cannot. So this I can rub it, right?
Yes, sir.
Okay. Now see this is a what triangle? Yes or no? Right angle triangle? Yes. Where this is beta, this is 90. Yes or no? Huh? And
Yes, sir.
this length is what? UE. Yes or no? Yes or no?
Yes, sir.
And what is this one? HI, height of image. So let us put it as height of image. Or I can, or let us not consider, first let us not write HI, right? This is A dash B dash. So this is A dash, this is B dash. So if I invert it, it will look like this. UE, A dash, B dash, and this is beta. Yes or no? Huh?
Yes, sir. Yes, sir.
If I say tan beta, if I say tan beta, what is tan beta? Perpendicular by base, A dash B dash divided by UE. Yes or no? Tan beta.
Yes, sir.
If tan beta is this much, beta is very small. Whenever beta is small, beta is very close to 0, then beta can be approximate to tan beta. So I can write this as beta equal to A dash B dash by UE. Clear? Clear? Okay. Now see, let us consider the magnification of the objective lens. What is the magnification of objective lens? You know the magnification nothing but HI by HO. Height of image divided by height of object. Yes or no? Huh? So for objective lens, what is the height of image? This is the height of image. That is A dash B dash. Yes or no?
Yes, sir.
And what is the height of image for objective lens? AB. Yes or no?
Yes, sir.
And you also know MO magnification is nothing but HI by HO divided by V by U or not? What is V? Image distance by object distance. Yes or no? Minus V by U. Yes or no?
Yes, sir. Yes, sir.
So what is image distance here? Minus V naught. And what is the object distance here? By U naught. Yes or no?
Yes, sir.
And this also minus. Why? Because they are opposite. So here also minus. So your MO is minus A dash B dash by AB is equal to minus V naught by U naught. So I can write that A dash B dash by AB minus A dash B dash equal to minus V naught by U naught. So both minus gone. So I can write as A dash B dash by AB equal to V naught by U naught. Yes or no?
Yes, sir.
So can I, if A dash B dash by AB is this much, can I write A dash B dash equal to V naught by U naught into AB? Yes or no?
Yes, sir.
And what is AB? Let me write as height of the object. So finally what I can write A dash B dash as? A dash B dash equal to V naught by U naught into HO. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now come here. What is beta? Beta equal to A dash B dash by UE. So let me rub it. I hope you have written down. I am not going to. So your beta is A dash B dash by UE. Yes or no? So your beta equal to A dash B dash by UE. Okay. So now in place of A dash B dash, can I substitute this value here? In place of A dash B dash, can I substitute this value?
Yes, sir.
So what I will get?
Yes, sir.
V naught by U naught into HO divided by 1 by UE. So finally I can write this as V naught by U naught into HO by HE. Why HE? Not HE, sorry, UE. Yes or no? Yes or no?
Yes, sir.
So this is the final beta. This is the final beta I got. This is the final beta. But for finding magnification, we need two things. What? Beta by alpha. So we know beta now. We have to find alpha. Clear or not? Till now it is clear. How did we find beta?
Yes, sir. Clear. Yes, sir.
So now let us come to what? Let us come to alpha. So here is alpha. This is alpha. This is alpha. So let me rub this. This is very important now. Compound microscope is little not tough. There is a derivation involved. So you have to understand the derivation. So now consider this triangle. Let me enlarge this triangle. So this is alpha, this is A, this is B, and this distance is U naught. Now what is tan alpha? Your tan alpha will be AB by BC. So AB is what? What is AB? AB is nothing but HO, height of object. So HO by U naught. Yes or no? Yes or no?
Yes, sir.
So now what do you know? That we should keep the object near the what? Near the D. D. If you want to see the object clearly, you have to place the object at D. D is what? What is D? What is D? Least distance of vision. Yes or no? 25 centimeter. So your U naught should be equal to what? D. So H naught by D. Yes or no, beta?
Yes, sir. Understood.
So if tan alpha is H naught by D, your alpha will become H naught by D. Why? Because your alpha is very small, close to 0. Very small. Whenever angles are small, tan alpha will be equal to alpha. Now we got alpha equal to H naught by D. You know beta. Now we have to find beta by alpha. Clear or not?
Yes, sir.
So divide out final magnification. M equal to beta by alpha. That is, beta is what? V naught by U naught. V naught by U naught into HO by HE divided by H naught by D. So H naught gone. So V naught by U naught divided 1 by HE into D. So this is the final formula. Understood? Understood?
Yes, sir.
So now if you visualize what is V naught by U naught? We starting we wrote no V naught by U naught equal to MO, magnification of the objective lens. Yes or no?
Yes, sir.
Similarly, what is D by HE? D is what? The distance at where the objective placed. And what is HE? What is not HE? No, sorry. It is not HE. UE. Sorry. What is UE? Where the object is there. So this is also, this is what? This is the magnification of the eyepiece lens. So you can write this one as MO and you can write this as ME. So your final magnification of the compound microscope is nothing but the magnification of the objective lens into magnification of the eyepiece lens. So this is the simple microscope. This part is only the simple microscope. Additional this one multiplied with this one makes it compound microscope. So if somebody asks you what is a simple microscope, you say this ME, and MO is an additional parameter which makes it as a bigger magnification. So MC, magnification of the compound microscope, is nothing but MO into ME. MO is the magnification of the objective lens. ME is the magnification of the eyepiece lens. ME, if you don't have this one, if you hide this objective part, this part only makes it simple microscope. Additional makes it what? The compound microscope. Understood?
Yes, sir.
Now, if I ask you what is the length of the microscope, then what you should tell? What you should tell? Oh, length of the microscope. The length of the microscope will be what? From here, this lens till this lens. So distance from here to here is VO. This is VO. This is UE. So the length of the compound microscope is nothing but VO plus UE. Why? Because simple, no? This, from here to here it is VO, from here to here is UE. So the total distance from this lens till this lens is what? VO plus UE, length of the compound microscope. Clear or not?
Yes, sir. Yes, sir.
Do you have strained eye? 1 minute, let me just check. Okay, you have. Fine. All of you is clear, no? So similar here also we have strained eye, and relaxed eye. Okay. So I am rubbing the diagram. So final is, what is the final magnification? Your MC is nothing but MO into ME. What is MO? V naught by U naught into D by UE. Yes or no? Compound microscope.
Yes, sir.
But we also have a maximum magnification. So obviously whenever problem asks what is maximum, you are straining your eye. So one is maximum magnification. Or they ask you strained eye. What is the magnification for strained eye? Then what you should tell? Whenever the maximum magnification is given, then you can directly tell your M infinite. Because magnification is infinite. Magnification is infinite. So you will directly say your M n infinite is V naught by U naught into D by Fe. Why Fe? Because if you want to get maximum magnification, that means you want to get the object at the infinite. Normally what happens? You get the final image here, but you are keeping it here. If you want to get this one very big, so you should keep ideally this one at focus. Yes or no? You know very well that if the object is placed at the focus, the image is at infinite. Yes or no?
Yes, sir.
So UE was here. Now I am keeping, maybe this is the focus. Focus, this side focus, this is the FO for this one, this side FO is for this one. So if I keep the object here, this image will be infinite because they will never meet. So if I keep this here, your UE is nothing but the focal length. Focal length. Yes or no? Focal length.
Yes, sir.
Of what? Eyepiece. That's why we are putting as eyepiece. So if somebody asks you what is the magnification of a strained eye, then you say M infinite is nothing but V naught by U naught divided by D by Fe. Why? Because this FO is somewhere here, but this FO is a Fe for this one, because this Fe is very big here and this is the Fe here. For this lens, your Fe is here. For this lens, the FO is here. So FO and Fe are coinciding. So instead of UE, you will keep a Fe. Is it clear?
Yes, sir. Yes, sir.
Oh, sorry, this is for relaxed eye. I'm sorry, this is for relaxed eye. This is for relaxed eye. Relaxed eye means maximum magnification. Now for strained eye, what you should have? What you should have? Your formula becomes MD is nothing but V naught by U naught by 1 plus D by FE. That's all. For relaxed eye, this 1 is not there. For relaxed eye, this is not there. For strained eye, 1 is there. That's it. The only difference the formula is for strained eye, for relaxed eye, this is V naught by U naught D by FE. For strained, this for relaxed eye. And this for strained eye. Strained eye, you have one more parameter, 1 plus. Clear? Yes?
Yes, sir.
So now let us do, shall we do a small problem? Okay, we'll do a problem. In a compound microscope, the focal length of the objective lens is 1.2 centimeter. The focal length of the eyepiece lens FE is 3 centimeter. You know very well that FE is greater than FO. Yes or no? So this is correct. When object is placed 1.2 centimeter, 1.25 centimeter in front of the objective lens. So let us draw the diagram. This is the objective lens. This is the eyepiece lens. So FE is 3 centimeter. FO is 1.2. So let us say this is 1.2. This is the FE. Sorry, this is the FO. Similarly here also FO and FE is 3 centimeter. So 1, 1, 1. Let's say this is 1, 2, 3. So let's say somewhere here it is the FE and somewhere here is the FE. So object is placed 1.2 centimeter. Sorry, 1.25 centimeter. So if this is 1.2, so object is placed somewhere here and this is 1.25. And what is the focal length? 1.2. So object is placed exactly after the focal length FO. Yes or no? It is asking us find. Find what is the magnifying power. Okay, the final image is at infinite. So final image is infinite means what? What formula you should use? Relaxed eye. Yes or no? The final image is at infinite means what? You have to use the formula for relaxed eye. What is the formula for relaxed eye? M infinite is nothing but V naught by U naught into D by FE. Yes or no?
Yes, sir.
So it is asking us when object okay, you have to find out what is the magnifying power. So if the final image is at infinite, what is the magnifying power? Okay, so now this is the formula. So you very well know M equal to V naught. This is the MO, this is the ME. Now what we should do? What you should do? You have to find the magnifying power. To find the magnifying power, what do you have? You check. You have FE. FE is there. You know. D also we know 25 centimeter. Okay. You know U naught. What is U naught? 1.25 centimeter. So what is missing? V naught. Yes or no? Yes or no?
Yes, sir.
So how to find V naught? So you have to find first what is the image. See, the final image is at infinite, but the image for the objective distance we don't know. Maybe somewhere it will be here. I don't know. So we have to find what is the image for the objective lens. So you have to find what is V naught. So what you should do? You have to use for objective distance, you use the lens formula. What is the lens formula? 1 by F equal to 1 by V by 1 by U. Yes or no? So since you are using for objective lens, let us put everything V naught. Why? Because you are finding for objective lens. So 1 by F naught equal to 1 by V naught by 1 by U naught. So what is F naught? F naught is 1 by 1.2. Yes or no? You have to find V naught. So 1 by V naught, and what is U naught? U naught is how what? 1.25 centimeter. Yes or no? Object is placed 1.25 centimeter in front of the objective lens. So U naught is 1.25 centimeter. So 1.25 centimeter. So what is 1 by V naught? Your 1 by V naught is nothing but 1 by 1.2 plus 1 by 1.25. Yes or no? But is it so?
Yes, sir.
Did you make any mistake? Nobody said me. See, uh, whenever you are calculating this side here, this side, you should consider minus or plus? Negative. So what you should do? You are supposed to do minus. So this will become minus. This will become minus. So if you multiply 100, so this will be 100 by 12 by 100 by 125. Yes or no? So if you take LCM, you will get 30, 25 minus 24. So your this will be 1 by V naught. So this will be 1 by 30. So your V naught will be 30 centimeter. 30 centimeter. 30 centimeter. That means your objective, your image will form very large. 30 centimeter. So what you should do? Let us substitute. Now you got 30. This is 1.25. This is 25. This is F is how much? 3 centimeter. So 30 by U naught is how much? U naught is how much? 1.25.
1.25.
D is 25 and F is 3 centimeter. So the value will come out to 310. So 250 by 125. 250 by 1.25. If you multiply 100 here, 100 here, so there will be 25,000 by 125. So if you divide this, this will become almost how much? 200. This will become 200. Clear? So the magnification power is how much? 200. Understood?
Yes, sir.
Clear, all of you?
Yes, sir.
So we have completed the microscope. Now we will come to telescope. Yeah? Telescope is there, no? Can you just check and let me know?
Yes, sir, it's there.
Derivation is there, huh? Completely. Derivation you don't have much, no? You want to learn complete or you want to learn shortcut? Because in your book it is not much given. Tell me. Whatever is given in book, I shall I teach you that one? Is it fine? Okay. So let us come to telescope. What is telescope? Why telescope used? Why Devika? Why is telescope used? It is a what? It is a device or instrument to view distant object. Yes or no? Huh?
Yes, sir.
Terrestrial telescope are two types. One is terrestrial telescope, one is astronomical telescope. Terrestrial telescope, if you want to see anything far in the earth, on the earth, maybe you are this is one building, this is another building. You want to see somewhere here. But astronomical is from earth to heavenly bodies. It's called astronomical. Okay. Obviously, astronomical telescopes are costly and they are very powerful. So the largest astronomical telescope, you know which one? Hubble telescope. Are you aware? Are you aware about Hubble telescope?
So you told about this in the last class.
Yeah. So can we see a video on the compound microscope, because that will help us to understand better. 1 minute. Huh? Compound microscope.
Sure.
Able to hear the audio?
To all them.
Able to hear the audio?
Yes, sir.
Microscopes are of two categories, light microscope and electron microscope. The light microscope includes bright field microscope, dark field microscope, fluorescence microscope, and phase contrast microscope. In the light microscopy, the magnification is obtained by a set of optical lenses using light waves. The electron microscope uses a beam of electrons to produce the image. The bright field microscopy is the most widely used microscope by students and other professionals. It is important to understand the working principle of compound microscope. In this microscope, the field is brightly lighted by using an external light source, and the microorganisms appear dark as they absorb some of the light. Usually, microbes do not absorb much light, but staining them with a dye greatly increases their light absorbing ability. Now, let us understand the working principle and construction of a compound microscope. Compound microscope has two convex lenses. The lens which is placed close to the object is called objective lens. The lens which is closer to the eye is called eyepiece or eye lens. Both these lenses are attached to a body tube. The body consists of an arm connected to a strong base. The coarse and fine adjustment knobs allow the two lenses slide in the body tube in order to bring the object in focus. Below the objective lens, there is a platform, also called a stage, and it has got two clips to hold the glass slide. A small aperture present just below the stage allows the light from the light source to the objective lens. Just above the light source, there is an iris, also called a diaphragm, which controls the amount of light passing into the aperture present on the stage. The objective lens has a shorter focal length than the focal length of eyepiece. In this diagram, an object AB is placed in front of the objective lens, just beyond its focus point FO. The light rays pass from the subject AB through the objective lens and form a virtual image A1B1 in between the focus point of the eye lens FE and the eye lens. Now, this magnified and inverted virtual image becomes an object for eye lens. The focus of the object A1B1 is adjusted by the eyepiece. Then, the eyepiece forms a magnified virtual image A2B2 of the object at the least distance of distinct vision, which is 25 centimeters for a normal human eye. Now, how to calculate the magnification. Most microscopes have 3 or 4 different objective lenses with different ranges of magnifications, usually 10x, 40x, and 100x. If the object is focused under a 100x object lens, the total magnification will be obtained by multiplying this value by the magnification value of the eyepiece, which is usually 10x. This gives a magnification of 1000x of the object. Hope you have understood the principle of compound microscope. If you have any questions, please comment in the comments section.
Clear? Students, clear or not?
Yes, sir.
Yes, sir.
So the only difference is what? Compound microscope is additionally giving a what? ME, whatever you get ME, MO is an additional magnifying power. So if it is 10x, if it is 100x, it is giving 10x, so total become 1000x. Clear? So this is normally used in biological labs. So it's called laboratory microscope. Compound microscope is also called laboratory microscope. Now coming to the telescope. So what is the difference between telescope and microscope? We'll study at the last. So let me give you that what telescope or telescope is a device which is used to view the distant object clearly. So what it is actually doesn't do any magnification. If I say telescope actually does not do any magnification, what it does then? It only brings the object closer to the eye. Okay, your sun, not like that ant looks like a dinosaur. It is only that ant is got closer to the eye. So if somebody asks, obviously we'll use the magnification formula. But however, if somebody asks you what exactly the telescope does, telescope, unlike microscope, does not magnify, but it gets the object closer to the eye so that it can be viewed closely and clearly. Understood? Note this point, very, very important point. Clear? Yes or no? So coming
Yes,
to
sir.
telescope. Telescope has again two lenses, but here the difference is the objective lens is a bigger lens and the eyepiece lens is a smaller lens. If you have seen telescope, telescopes are like this. Yes or no? Have you seen telescope?
Yes, sir.
They are like this. So this is the objective lens and this is the eyepiece lens. The eyepiece lens, the FO and this is FE, the FO is greater than FE. In compound microscope, it was ulta. It was like this. Not so much. FO is smaller than FE. So the difference between